Hello everyone, my name is OtavioSantana. I'm glad to be here and welcome to my session around persistence made easy with Jakarta Data NoSQL. I know we usually don't talk about persistence, especially because it brings a huge challenge for us. But today, let's face it, my name is Otavio Santana. I am the Senior Engineer at Soup Innovation, and I did not do this presentation alone. I did with Corina Varela, who is Principal Technical Marketing Manager at Red Hat. So if you want to know more, please follow us on Twitter and also send us a message through emails and social medias and so on. Today is not to talk about us. Let's talk about challenging around persistence. Soft architecture brings a huge challenge for us. It's hard, it's tough to handle with that. Especially because uh, it's a huge word, right? It's not only about code, it's to understand the product, to write ambiguous language, and so on. If I can split the layers in our application, you can think more about okay, each was the hardest part, the application design or the persistence design. Both, as I mentioned before, has challenge. However, if you try to measure the number of information around application design, we have much more information around it. For example, we have much more maturity models, we have more design partners around application design than persistence layer, right? We have the Richardson maturity model around the REST application or Glory REST, but how many persistence maturity models do we have? How many of those are popular to use and take advantage of it? And that's the initial point. The initial challenge is exactly around that because we have a broad knowledge around architecture, how to refactor the code, how to create and design good design partners around my application. Documentation, not so much, but indeed we have. Tests, oh come on, it's even worse, right? I mean, we enjoy to talk about microservice, but we do not enjoy to talk about documentation and tests. Who cares about those, right? And on a persistence layer, we have much more database, at least the most popular ones. We have a huge number than language. We have several paradigms around persistence layers, and mainly we have a lot of database flavors. We have SQL, we have NoSQL, we have NewSQL, and each persistence layer has your own particular behavior that's matter. That's one way to take decision to choose Cassandra instead of Scala or Mongo instead of Couchbase and so on. The main point here of our discussion is uh, those matters a lot to us. And when you go deep on or around database, oh, it's a nightmare. Especially because we need to design a model, especially when you talk about relationship where I need to write a schema, then write an application, right? It's not a schemaless application. And it's usually the first thing that we do. On that time, we often have no idea about the maturity of the product. And the refactoring inside the code is cheaper, right? I decide to use some IDE, I use some shortcut and then do the refactoring and check if everything is okay. However, on the persistence layer side, it's tough. I need to do the migration point, I need to check the consistency of the data, and in a time where the software, every company is a company software by forms, The data is the soul of the company. And as much the application go evolve, as much the application gone up, increase the experience, or that you keep maintaining the evolutionary data around the application layer. So it's a huge challenge where we hardly ever listen to some challenge around migrations and points like that. On NoSQL and SQL, as I mentioned before, we have over 400 database options. It's a huge number, right? And we have at least those categories. So we have column family or wide column. We have graph database. We're able to do recommendation engine, document like MongoDB, key value, uh, relational database. And remember, NoSQL has much more than those types. Those one here are just the most popular one. We have, for example, time series database. Okay, it's a shallow idea around NoSQL, SQL and NewSQL. We have a huge word around it. And we have more challenge. So please don't cry while you're watching my presentation, but it's a huge nightmare when we talk about persistence layer and we don't do it often, right? We have our application who has one paradigm. We usually use object-oriented language like Java, and we often use relational database where we need to design our database to do relationship, of course. As you can see here, we are able to see a mismatch between the language and the structure inside the language and the structure inside the database. And it has a cost to do the conversion and the communication and translation to and from objects in Java or to or from relational information in the database. And that's why we have a new word, impedance mismatch. Why? Because application in Java has heritage, polymorphism, encapsulation, and types, and design partners. A lot of things that we do have in our application side, but we do not have on my relational database side, or my SQL side, or my persistence layer side. So we need to handle with normalization when talk about SQL. We need to handle with the normalization when talk about NoSQL. Query-driven model like Cassandra, MongoDB. So we have our database structure, we have our application structure, and we have a loss when you do a communication. It doesn't matter if I do it manually, where it will consume a lot of boilerplate, or I decide to go to use a framework like Hibernate or Jakarta NoSQL, anything JPA or something like that. Somebody needs to do it for us. And again, it has a cost. And as software engineer and as an architect in our application, in our system, or in our company, we are sick of priorities. Of course, when we write a code, it's around business, it's around product. So we want to write our application around the business with ubiquitous language from DDD. So priority number one is business. Then we want isolation between the business because it has the higher priority in us and anything else like technology, especially because an application must have at least to survive for 3, 5, 10 years. So if my application needs to refactoring again after 2, 3 years, it might not be a good sample of evolutionary architecture. And of course, we are seek for performance. So we want isolation on one hand to focus on a business, another point to have a better model to improve our database to return information faster and faster and faster. Maybe the fastest in the market. Why not? Again, business, DDD, isolation, clean architecture, for example, and performance. Take advantage of the persistent layer that I decide to use. So if I want to use Cassandra, I want to take advantage of consistency level, of scalability, a vertical scalability, and so on. If I want to use SQL, I need to use normalization, take performance to get more consistency inside of my persistence layer, and so on. So, business, isolation, and finally performance. Okay, I mentioned a lot around the challenge around application, architecture, design, and but how do we handle persistence in Java? How hard is to make it possible? It's a valid question, right? How can I make it possible and valuable to my application, to my organization, and to, of course, to everybody? Uh, when we talk about architecture, how much effort would you like to take to change? The world happened, right? So sometimes I started my product with a service, and right now I find another one that is cheaper, or I'm using on-premise application solution and then decide to move to the cloud, or I decide to change the cloud. So I'm using Amazon and then decide to move around Amazon uh, to Google Cloud, or something like this. Sometimes we started with SQL and then decide to go to NoSQL, or the opposite. So I started with NoSQL because I don't know, I want to use, I want to explore, and then decide to swap to SQL because I'm more seeker for consistency than performance or vertical scalability. And by the way, SQL is still relational database, still a good solution. It has several success cases around scalability. So if you want to use NoSQL only for performance, only for scalability, please check again. So SQL has a huge and maturity history around persistence layer. And the last question is, can I or may I change the framework around the evolution of my product or my solution or my company? Those are valid questions, especially when you are a senior engineer on your product or you are an architect or something like that. And yes, especially around Java, persistence has a huge word, and we need to handle with those topics more often than we would like, right? So database server data, the configuration, where should I put those configuration, those connections? Can I use the traffic application, or should I use vault or something like that? Connection handling. Legal connection is still one of the biggest issues that I found that is hard to find, at least on my side. Mapping classes to table and do the conversion. As I mentioned before, we need to think and figure out how to handle my application, my design and object in my database or my persistence layer. It doesn't matter if I'm gonna use SQL or NoSQL. I need to take the advantage of my persistence solution. I saw an amazing presentation by Givy King, who created the Hibernate, the open source ORM. He said, nobody should use Hibernate because they are scared to learn SQL. The idea or the main idea around Hibernate is to reduce the boilerplate to work on SQL. Exactly, to use this time to take more advantage on both sides and on Java and also in the database. The mapping class relationship, the transactions to get persistence. And of course, we have much more ideas. The custom queries, should I use it caching? How much entry should I put? How much layers should I use in abstraction of the database? Should I decouple the business logic between my persistence or not? Those are some questions that we usually do when we talk about Java, persistent Java, and database. Okay, so those are the most often questions that we do: connection, mapping, developer experience. I mean, how can I make the code easier to us or to everybody, and so on. And let's go deep, especially when talk about Java and application. Let's talk about the structure that we usually face when we talk about frameworks. Java frameworks, they have several types. Okay, so we are able to choose one closer to the database and far from the code, and the opposite, an API who is able to be agnostic. I mean, you're able to use one API to many solutions or one specific, and so on. Okay, so we have two kind of categories. The first one is how far my frameworks put me on the database. For example, here we are showing JDBC. That is a driver. This one is of course closer to the database, and that give me more flexibility if you look for the database side or the persistence side, because the result set is a structure from the database itself. The query is a communication. We are able to run and explore the data-driven design application if you do it this way. However, if you do with objects, you might have a complex relationship with your business logic. It is no good, right? So nobody wants to be far. Or if you want to use object, you need to handle with several boilerplate around it. It is also not good to go. So again, challenger of driver. Driver is the one closer to the database, far from the object business. You get more flexibility looking for the persistence layer, but we are far from the business. So we need to do more code to make it possible. Or you're able to do the data-driven design. Let's go to the opposite. Let's use any kind of mapper. So I have my object here, where I have my entity. Remember, the entity is one concept from DDD. This case here, it's a person where I have the name, the birthday, and the address that has many-to-one relationship. And as you can see here, I put my business value in this person, in this entity person, and I become far from my database aspect, where I need to pay more attention, right? I need to avoid the n+1 query mistake. There are several aspects that you should pay attention more when you do with data mapper. The advantage is, yeah, I'm closer to the business, so I will use object. I have a person, for example, has a list of address where I just put some annotation and they will mapper everything for me. And that's cool, right? So it will reduce my time. Based on mapper, we have the active record, where the main point or the main goal here is around I have my entity mapping class. I extend an entity where it has several database operations for me automatically. So I don't need to pay much attention on it. So it's much cheaper to generate value around integration between my object, my entity, and my database. As you can see here, I have my person, this time with active record, using heritage to extend my Panache entity by Quarkus, where I will create my person instance, and then I will persist my application. Oh, it's done. I don't need anything else. I want to list everyone, list all method. It's a static method. So fancy, right? I want to do a find by ID. When we do with simple business application, it will decrease a lot. Uh, it will decrease a lot the number of code that I need to do. Instead of I put several layers, I have my domain that has the database responsibility and then my controller application. Less layers, less class, and it might be less bug. However, I have a vendor looking here. As you can see, it's hard to change between my solution. So if I'm using Panache here, if I want to choose another active record, it might be a nightmare. Or if I want to choose between SQL and NoSQL, it might be a nightmare as well. Especially because I need to change my array. I need to extend for Panache MongoDB entity, for example, if you want to switch between SQL and MongoDB. It is a NoSQL document solution, by the way. And also, I have the issue around how can I say, the single of responsibility, my S inside my solid. Why? Because I have my person who has the responsibility to be a person. That might be several rules. So for example, it doesn't make sense to my birthday be tomorrow. So I need to validate that. I might have several methods to around person. And also I need to handle with my persistence as well. So I have my person who has domain responsibility and my database responsibility. Is that right? Is that wrong? It depends of the context that we are working it. So everything has a trade-off. Please pay attention to it. And then the another solution around mapper, remember mapper far from the database and closer to the object. That's different from driver. I do have my repository. The repository do a mapper, as you can see. I have my encapsulation, my person repository, and at the end, I don't care about any operation. For example, here, I'm doing the person repository, I will inject my repository, and then I do a save. With my active record, I do a list all, and with my repository, I do a find by ID. Where this data comes from, I don't know. It might come from a SQL, it might come from a NoSQL. The reality is I don't know. There are several questions around the main difference between repository and DAO, data access object. And for me, the main one is the repository is an abstraction on the business perspective. So we have several method persistence that represent my collection, where at the end, I really don't know where this data comes from, and it should be transparent to my client. And with DAO, instead of save, I might have insert, update, delete, and something like this, because it's a data access object. So the whole operation is in DAO. When talk about solutions around relational database, we have, of course, the most popular standard that is JPA, Java Persistence Application, who has several influence in a lot of technologies like Quarkus, like Spring Data, like Micronauts. It supports several design patterns, so you're able to use active records with JPA, like Quarkus are doing. You're able to use repository with Spring Data JPA. You're able to use data mapper as well. It's a huge mature stack around Java for a while. So since 2006 and the Java EE 5, we have a long history of this API, of this framework. So we are talking about almost 20 years specification. However, as I mentioned before, we have more solutions, we have more deals to handle it, like NoSQL. And when do with NoSQL, of course, JPA is not a good idea, especially because NoSQL has several particular methods or behaviors that make sense to SQL. However, it doesn't make sense to SQL and so on. For example, uh, time to leave object. So it makes sense to know SQL, but might not make sense to SQL as well. So JPA is not a good solution. It's like you try to use a knife instead of a fork or so on. So JPA is relational, and we need a standard to know SQL. And that's why it was born Jakarta NoSQL. It's a Jakarta EE specification. It was the first one around. And the main idea is to make easier to us Java developers to explore Jakarta and Java with NoSQL database. The idea is to be annotation driven, be an easy API where you're able to a couple of annotation to switch between SQLs. Oh, sorry, between switch between NoSQL database, especially between types. So the API has four different types for now. So column family, graph, document, and key value, where we have the same annotation to work on those types, and each type has one API to communication. The exception is a repository. Okay, but in general we have more APIs. So for example, column family has your own template to do a basic operation, graph as well, document as well, and key value as well. And in NoSQL, the particular behavior matters a lot. That's why we have extensions. And we don't want to reinvent the wheel. So we have in graph, we are using Apache Tinkerbox. The main motivation around Jakarta NoSQL is, okay, we are not talking about a high and heavy specification around NoSQL database, especially because the particular behaviors matters on NoSQL database side. However, there are a couple of behaviors that everybody has, like the CRUD operation. Everybody does create, retrieve, update, and delete information. As you can see here, we have four different NoSQL database. Those are document NoSQL database, and everybody are trying to do exactly something to insert a document inside my document entity or my database. As you can see here, and around DB we have the base document where we are inserting the name and value. Both combined makes the document. MongoDB the same, document append, Couchbase the same with JSON object, and RNDB exactly the same. Everybody is doing exactly the same. The main difference is just the class and the nomenclature. However, those have the same behavior. And that's the main motivation behind Jakarta NoSQL or JNoSQL as a reference implementation. Instead of I need to learn new APIs to every single NoSQL database type, let's use one. On this case here, it's a document, and then switch easily between them. And as I mentioned, we also have a challenge around the persistence partners. We don't have enough, we don't centralize that. And of course, we are working on it on Jakarta side as well. Right now we are working in the second specification that was born in Jakarta EE. The second and third one, I don't remember. The idea is to be a data partner where the main goal is to be more agnostic around database. It was approved. It's an initial phase, so please join us to discuss the ideas around SQL, NoSQL, SQL. The idea is to have several standards around Java, right? I mean, okay, I'd like to use Micronauts. I'd like to use Quarkus. But usually the concepts are the same. Why not use the same concepts on those? For example, here, the repository does not belong to the framework, but belongs to DDD. Why not standardize this as a specification? And that's the main goal of Jakarta Data. Of course, it is the first step. The idea is to have more. So repository with pagination, if without pagination, CQRS, event-driven design, DTO, who knows, and so on. And to make our life easier, I know we have a couple solutions, a couple discussions, a couple challenges that we mentioned that we should pay attention. Okay? But as Java developer, we are lucky because we have three specifications to handle and to make our life easier. So JPA to work with our life easier, our relational database where I'm able to use repository, I'm able to use Active Record or Mapper, Jakarta NoSQL to work with NoSQL, and Jakarta Data where the main goal is to standardize or define patterns around data agnostic solution. So it doesn't matter if you're going to use SQL or NoSQL. If I use repository, it has abstraction layer to make my life easier to switch between those. And that's all for today. So thank you everybody. Please, if you have a question, please let us know. Please follow us on Twitter. As you can see here, those are our social media. So at Otavio Java on Twitter, YouTube, LinkedIn, and so on. And Corina Varela, Varela, but instead of A, it's a 4. Okay. Thank you everybody. Hopefully see you soon. Bye.